right, in this lesson, we're going to be talking about how we solve quadratic equations by using factoring. And the one thing that you need to understand is that the reason that we're able to use the process that we do is because of the zero product property. And what that says is if A times B is equal to 0, then A has to be equal to 0 or B has to be equal to 0. Because in order to get 0 when we're multiplying, one of the numbers has to be 0. So the other thing that you need to understand is if we have a quadratic equation, f of x equals x squared minus 9x plus 18, if we were to factor the quadratic part of it, we would have x times x. The factors of 18 that add up to 9 would be 3 and 6. Because this is positive, these both have to be negative. Negative times a negative is a positive, and negative 3x and negative 6x gives us negative 9x. Now, remember when we are working with any equations and solving, if we want the x-intercepts, we let y equal 0. And using the zero product property, we know that if this times this equals 0, that either the x minus 3, let me write that over here, x minus 3 would have to equal 0, or x minus 6 would have to equal 0. And if you just add 3 to solve for x would either equal 3 or x would equal 6. So these are called the solutions of the equation. These values here, when y is 0, x is 3, and when y is 0, x is 6, those are the intercepts of the equations. They're also referred to as the zeros of the functions. So when we're working with quadratics, when we're solving them, we're looking for the x-intercepts, which can also be called the zeros. They are the solutions to the equations, and also, the solutions to the equation, and also they're called the roots. So those are words that you always mean basically you're factoring and solving. How do we solve? We factor the equation, we set each factor equal to 0, and then we solve each equation for x. So what are the solutions of the quadratic equation? So first we factor. So we would have x times x. Okay, factors of 6 are 1 and 6 or 2 and 3. But since this is positive, it means we either have to have 2 positives or 2 negatives. So in order to add up to 6, it would have to be 2 and 3. So negative 2 and negative 3x gives us the negative 5 in the middle, and that's equal to 0. So now using the zero product property, we set each of those equal to 0. And then we can solve. X would equal 3 and x would equal 2. Now, if you substituted both of those back in, like if we substituted in the 2, we would have 4 minus 5 times 2 is 10 plus 6. And does that equal 0? Negative 6 plus 6? Yep, that equals 0. Now let's substitute in the 3. 3 squared is 9 minus 3 times 5 is 15. That's negative 6 plus 6. And yes, that equals 0. So both of those work, and those are the 2 solutions. Here's another one. Now, when we are solving quadratics, we always want to have 0 on one side. So let's bring 12 to the other side. So we have x squared minus 7x plus 12 equals 0. So now we'll factor and set one of the factors equal to 0. So 3 times 4 is 12, and 3 plus 4 is 7, and negative 3 and negative 4 gives us negative 7. And so if we set each of those factors equal to 0, x equals 3, and solve, x equals 4, and those are our solutions. All right, it says find the zeros of the function by rewriting the function in intercept form, and what intercept form means is factored form. So we want to find the zeros. So we find the zeros when y is equal to 0. So now we factor. So it's the same type of problem as we did before, but just different terminology. Factors of 14 are 1 and 14 or 2 and 7. So let me see, 7 plus 7 minus 2 would give you 5. 7 minus 2. So 7x minus 2x would give you your 5x. Set those factors equal to 0. x equals 2, and x equals -7. All right, and let's go over and do this problem right here because this looks a little different. Now here we don't have a trinomial, but if we look in both of these terms, we have a common factor. So we're going to take that out. So an x, we can take an x out of both terms. So we would have a 1x here plus 5. So now the factors we have are x times x plus 5. So we set those factors equal to 0. So x equals 0 is one solution. And set the x plus 5 equal to 0. Subtract 5 from each side. So x equals -5. There we go. All right, so now we have a word problem. It says a town has a nature preserve with a rectangular field that measures 600 meters by 400 meters. The town wants to double the area of the field by adding land as shown. Find the new dimensions of the field. Well, let's see. The original field is 400 by 600, and area is length times width, so that's 240,000. If we multiply length times width. So the new dimensions then, this new width would be x plus 400. The new length would be, let's see, x plus 600. So I'll write it on this side. And we're looking at the area of a rectangle, and I'll write that formula down. Area is length times width. So the new area, we want to double it. So instead of being 240,000, it would be 480,000. And the length is x plus 600. And the width is x plus 400. So to solve this, we're going to have to simplify, and we're going to FOIL the right side. So we'd have x squared plus 400x plus 600x plus 200. Sorry, that's a 240,000. And that equals 480,000. Now, whenever we're solving quadratics, and I know it's quadratic because there's an x squared, we need to get 0 on one side. I'm going to subtract the 480,000 from both sides. So we have 0 equals x squared plus, okay, the 400x and 600x, if we combine like terms, is 1,000x. And then 240,000 minus 480,000 was a negative 240,000. So now we're going to factor, and those are some big numbers to factor. But let's ignore some of the zeros here and think about factors of 24. 100 minus 200, 1,200x minus 200x. That would be 10,000x. Or excuse me, 1,000x, 1,200 minus 200. So that is the correct factorization. And so now to solve, we set those equal to 0. And so x would equal 200 and x would equal 1,200. Oops, a negative 1,200. Now, if you look at these solutions, they don't both make sense. The negative number would not work because if we look up here, x cannot be a negative length. So we throw out that answer, and the answer is going to be 200. And if you substitute that back in to the problem, that would make this 600, and that would make this 800. And 600 times 800, that is 6 times 8. 6 times 8 is 48, and so that would be your 480,000. All right, we're also going to do some factoring that's a little bit more complex here. So we have factors of 4 are 1 and 4 and 2 and 2, and the factors of 3 are 1 and 3. So we know that it has to be 1 and 3. So let's try 1 and 4, x. So that's 3x and 4x. That won't work. Let's switch it. So it's 4 and just a 1x, that would be 12 and 1, so that did not work. So let's go to the 2 and the 2 here and see if that works for us. That would be 2 times 3 is 6x, and this is 2x, and we would want to have a negative 4, so 2 minus 6 gives us a negative 4, and there we go. We have it factored. And now, just using our zero product property, we have 2x plus 1 equals 0, 2x minus 3 equals 0, and we have to solve this equation. So first we would subtract 1, so 2x equals a negative 1, divide by 2, x equals negative 1/2, and we have 2x equals 3, divide by 2, so x equals 3/2. Those are your solutions to that one. Here, we don't have 3 terms, but if we look, we have a common factor that we can take out. We can take out a 3x. That gives us x minus 3x divided by 3x is 1, and that equals 0. And again, we have this factor times this factor, and so we set each of those equal to 0. Divide by 3, 0, divided by 3 is 0. So that's one of your solutions, and x minus 1 equals 0. X would equal, if you add 1, 1. Here again, next one, we'll take out our common factor. So we have 16x squared minus 1 equals 0. Now when we're solving, it's a little bit different here. We're not going to need to keep this 2 here. When we have something times something, we can divide one of those factors on both sides by one of those factors. 2 divided by 2 is just 1. So that would be 1 times 16x squared minus 1. 0 divided by 2 is 0. So when there is a constant out front, just divide that out from both sides. Now, this, if we notice, 16 and 1 are both perfect squares, so it's the difference of 2 squares. And then now we will set both of those equal to 0, and then you would solve those. So here we would subtract 1, and then divide by 4. So x equals negative 1/4. Here we would add 1 to both sides, divide by 4. So x equals a positive 1/4. All right, last one we're going to do here. Now this one is probably the most challenging because if you look at your A value, your beginning number, the factors of 12 are 1 and 12, 2 times 6, and 3 times 4. So it's going to be one of those. Factors of 15 are 1 and 15, and 3 and 5. So we have a lot of different combinations that we might have to try. So what I do first is I list them, and oftentimes I start at the bottom of the list, so 3x times 4x, and then we can try 1 and 15, we could try 3 and 5. I start at the bottom, we'll do that again, 3 times 5, and to see if that would somehow give us 11. So 3 times 5 is 15, 3 times 4 is 12. That's not going to work. So let's switch the 3 and the 5. So that would be 20x, and 3 times 3 is 9x, and that's going to work because if you take plus 9 minus 20, that would give you a negative 11. So the negative has to be in front of the 5, and then this would be a positive. And so those are the factors. Now, if the 3 and 5 didn't work, then I would have to try the 1 and the 15. And if that didn't work with the 3 and the 4, then I would try the 2 and the 6 with both sets over here. And so it just takes a while, but you just keep trying all the combinations until you get one that actually works and is equal to what you started with originally. So now you set each of those equal to 0. Oh, there should be an x right there. And solve. So 3x equals 5. So x equals 5/3. 4x equals negative 3, and divide by 4, x equals negative 3/4. And that is this lesson. Let me know if you have questions. Thanks for watching.